Hi everyone, welcome back to my devlog for my Monster Rancher companion-ish type clone. My name is Nick Sullivan, Sullivan Creative Studio, and just to recap, I'm, like I said, making a Monster Rancher clone where you have a little companion, a little monster, or whatever, that you can train at whatever training thing that you put on your little ranch, farm, home base area. And yeah, you train their stats and they increase or decrease depending on different factors. But today I'm actually here to show you my AI combat, the start of it, and I'm actually really excited about this. It's the one thing that's kept me from progressing on the paintball game that I've been posting on here, because AI is a beast. I do not like Unreal's behavior tree system. It's just it's a whole nother thing to learn when it's a blueprint, but it's not really a blueprint. So tasks, decisions, behavior trees, stuff like that, I didn't want to deal with it. So instead I'm learning more of how blueprints work, and here it is. I'm doing it based on a decision scoring system. So based on different factors going on in the world, a action will get a score, and the highest score will be what the decision chooses. So yeah, it's working. It's sitting here working. So I have the current state at the top here, and by the way, my hand's completely free. See, hands right here. It's doing everything by itself. So we have the current state that's doing. So right now it's roaming. Now it's moving towards the enemy to do some melee attacks. It's got its health, its mana, which is really its like ranged attack system, and then its stamina, which again is its melee attack type of using the system. So you'll see there's two columns here. There's booleans on the left, and then the scores for whatever actions on the right. So the booleans are melee range, if you're in melee range, true or false, just so I can see if the range is working. And then ranged attack range, true or false again. And I'll show you a little bit more in depth later. But right now I'm just kind of quickly going through it. On the right side, you'll see all the scores. Depending on what's going on, it's going to output a score, and whichever score is highest between 0 and 1 wins. So it's kind of like a percentage. So right now, you'll see that his stamina is 20. He's roaming, but as soon as he sees that it gets a little higher, he's like, oh, wait, we need to move to the enemy because we can attack. Now we're attacking. Okay, now we don't have enough stamina to attack, so we're going to go back roaming because that's the next highest. All of this is done with booleans, branches, true, false, if statements, whatever. Just to see what's going on. Are you in range? Do you have enough stamina to attack? If so, add a certain amount to the score. If that's the highest score, do the thing. That's basically it. It's very simple. And I'm super proud of it, actually. A lot of people call this a utility system. I haven't found a whole lot of good tutorials on how to make it work, so I'm going to show you guys a little bit about how I make it work. But for the most part, this is it. I'm going to get it more fleshed out, add more features to it, add an attack cooldown or like attack rate kind of thing. Obviously more visual. Like when you attack, it shows the numbers. Random damage numbers right now is just not doing anything besides the conditions, which is great. But yeah, so on to how this all works. I've created an enumeration with all these different values. The ones I'm using right now are from move toward enemy down to roam. Hide is for future. Do nothing is debugging, but I also might use it as like a stopgap for roam. And then I've created a blueprint component that attaches to the AI that just really holds variables. That's it. All the variables that I'm going to use in the game. There will be more, but this is what I'm using right now. And when I update this and I compile the AI as well, it will allow you to use any of those variables. Besides that, we've got the AI controller companion, This is for your standard top-down when you're doing the trainings. All it's doing is setting the enumeration value with this event. Same thing with set combat state. We're setting the combat state enumeration, which is what we saw earlier. And then you've got the UI that's looking at everything. So to get into this part, it's going to be a little dry, but if you're interested in how the system works, please stick around. If you're not, then, I appreciate you stopping by, checking out the progress. Thank you. But we're going to get into the nitty gritty. Kind of a summarized version of it. But event begin play. So when the game starts, when this level starts, we get references to the AI controller. We can actually get rid of this. This is to the top-down character in the training level. But we get that reference, set a variable, cast to the game mode, get that variable. Then we have a function for start play stats. This function actually just kind of holds all of those stats that you saw in the blueprint component, the BPC stats, and it lets us set them right here. So we're setting it to 100. Health matches at the beginning because it's your max health. Strength, speed, loyalty, all this will be set in the future by your training level companion. So when we move from the training to a different level, it's going to save those stats in another blueprint. I haven't looked at it yet, but I know you can do it, obviously. But you put all the stats up there, and then when you start, you actually drag a ball back into here. That way they're updated. Same thing with your stamina, mana, and stamina rate increase and mana rate increase. That's how much of that stamina are you, or sorry, how much of that resource you are getting back every so often, every couple of seconds. But yeah. So that's that. And then if we go back, sorry, there's a lot of stuff going on. We then get all actors with the tag enemy, and we store them in an array for all enemies with that tag. That's just so if we have multiple enemies on the board at a time, we can store all of them in there. Later on, we'll use it to get the closest enemies so we can actually start making decisions. After that, we start the default state as Rome. So he's immediately going to just kind of move around a little bit on the map before he does anything else. And then we do state change. So this is an event to change the state, which is right here. All this does is it controls, okay, if we move to this state, we do this custom event or function if I make it a function. So we have move toward enemy, away from enemy, attack melee, attack ranged, and roam. Pretty simple. And then these are very simple, just here's roaming, set delay for a second. You get your actor location, get a random reachable point within the radius, whatever you want. AI move to, and then we check if we're still in the state of roaming. If we are, on success, then we just loop it back around, wait a second, and continue. Really simple stuff. Seems simple. It took me a while to figure out how to do all this. It's been about 3 weeks of me just trying to figure it out. Different systems, different things, different... I can't even explain all the different iterations I've gone through. But yeah, so state change, whenever we want to call that, hey, this combat state has changed, we switch what we're doing based on what the enumeration value is, which is right here. Inside the AIC companion, which is the AI controller that we showed earlier. Besides that, we'll just go into the event tick. Some of this we can definitely move out of event tick for right now, like the first portion of it. And I'm sure I'm using a sequence wrong. I'm sure I am, because I've got multiple delays in here, and I don't want this to delay this, but they are, maybe. I don't know. I haven't gone through it yet. Still pretty new to how sequences work. But I did try and keep at least a hierarchy here. So the first thing we need to be doing on event tick is figuring out who our closest actor or closest enemy is. So we get actor location, find the nearest actor from our all enemies array. We make sure that whatever it returns is valid, otherwise it might continue to give errors in the background, but otherwise we're just making sure it's valid. If it is, then we set that return value to the closest actor, or closest target, enemy target. And then we use this neat little event function. It's a function. Neat little function to see, okay, well, the enemy that we're feeding into it from here, that enemy, checking to see if he's still valid. If he is, get his location, get the AI's location. Then we have it find look at rotation and set the new rotation for your AI person. And that's it. That way he's continuously looking at him. Like right now, this is your AI companion. This is the enemy. Right now, they're not really looking at each other. But as soon as I hit play, immediately looking at him. And then you'll see kind of the weird movement. He is always looking at the enemy. Essentially, that's what the camera's doing too. It's always looking at the location of the AI companion. That'll change. I'm probably going to have it to where it tries to keep both actors in focus based on another tag. But for right now, this is how I'm doing it for debugging of the scores. Besides that, we've got the next thing, which is just stamina increment over time. We said delay for every 5 seconds, it goes up. And this again is a custom function. It looks scary, but it's really not. A lot of it's just this guy and all the references. But essentially what it's doing is checking to see if stamina and max stamina, if stamina is less than max stamina, basically. If it is, then you increment it by whatever value you have here for stamina increase, and then you set the new stamina. If it's false, if it's not less than, so if stamina is not less than max stamina, then you set stamina to be max. That way it's never higher than the max stamina. We could probably circumvent that if we wanted to for like, say Halo's overshield. If I have a pickup on the field, the AI decides, oh, I need to go get that to get more stamina, like a stamina boost, so we can just keep attacking. But, you know, you could probably do that with another branch. But for right now, this is what we're going to use. Same thing goes for mana. Same exact system, same exact thing. Again, it's spaghetti, but it's actually pretty simple. From there, we are getting ranges. So we're getting that closest target that we have set up here on tick. And we're constantly checking to see if it's within melee range and if it's within ranged attack range. And then we're returning those values like you see here. So right now he's in ranged attack range, but as soon as he's done, he moves into melee range. He's in melee range, so the melee attack score goes up. If he's within ranged attack range, that score should go up. But we're using this just to try and increment those scores, like influence, I should say. The last thing is, okay, now we need to make decisions. So instead of, like, if I got rid of this delay, we're just gonna circumvent it altogether. If I get rid of it, it's gonna be really, really weird. He's just gonna start doing stuff like instantly, which obviously is not natural. He's just moving. As soon as he finishes something, he moves on to the next one. It's actually not as bad as I thought it'd be, but we don't want this to be a constant thing. We want it to kind of think and try to make decisions. So right now we're delaying it by 2 seconds. We'll do it with a random variable after that, but for right now, just 2. Then it makes decisions. This is the meat of, well, actually, this is kind of like the brain. This is the decision maker. This is the brain of the whole system. When we go into this, you're going to see not a ton going on. You've got these functions, which are what creates the scores. You have the output of the scores for each of those functions. They go into an array. We get the highest value of that array, and then we just check to see if that value equals any of these. If 0 equals 0, on this multi-branch was just really just multiple branches thrown into one node instead of having this crazy looking thing. But you check to see if 0 is the highest. If it is, it's going to go through this condition, and we just want to set state roam, which is what it's supposed to do. Action score roam. We're throwing in what that score is. We're checking to see if it's equal to the highest value here. Checking it. And if it is, throws it out. And then we do the state change custom event, which we saw up here. State change custom event. And it just changes it to roam if it's the highest number. But we do that for all of these right now. Melee attack, ranged attack, move to melee range. Depending on what the scores are, which I'll show you in a second, how they're added up. They get thrown into the array, they get checked, yada yada, and they set roam, attack melee, attack range, move towards enemy, and always run a state change afterwards. So let's get into roam. Again, really simple. Another multi-branch. We're checking to see if the stamina is less than or equal to 20. If it is, then we go to condition 0. Simple as that. Condition 0 then goes up to set the roam score. So this is the default score. If you don't end up setting this, you're going to continuously increase or decrease that score depending on all of these factors. So if I didn't do this and I just said we set the score to plus 25, every single tick that it decides what score it needs to be, it adds 0.25 every tick. This way, we get it set back to the default score, and we can manipulate that default to then stay within our 0 to 1 score. Notice nothing ever hits 1 yet. I'm doing that on purpose to where I don't want a number 1 unless it is something that absolutely has to happen, like an ultimate attack. Hey, I've got my ultimate attack. They're this far away or whatever. I need to do this now. But for right now, nothing goes to 1. But if we don't set that back at every single one of these, then it will always go over and over and over and over. You could have 500 within, I don't know, 10 seconds maybe, depending on the tick and delays. So set the default every time. Then you add your score for however high you want this to be. This is anything. Honestly, you could go from 0 to 100. I'm doing 0 to 1 just to make things simple. But after all said and done, you just throw out what that score is into the return node, and that is what you see coming out of the function here to make the array. Same thing goes for all of the others. The action score melee, we're checking to see if stamina is greater than or equal to 20.1, and if he's within melee range. If he is, then we add a whopping 0.7 to the default 0.2, making it a 0.9, meaning it's probably one of the higher ones out there, so he should be doing that. We'll put randomness in this too at some point. Right now we're doing this just to make sure it's working, and so far it has. Not flawlessly, but pretty damn good to where I'm pretty happy with it. Same thing with ranged, exact same thing. Mana greater than or equal to 20.1. Is he within attack range? If so, 0.7 to 0.2 in output. But yeah, that's the system. These over here are just the move tos, move away from, which is not currently working. I don't know why. Haven't really figured it out, but if he's actually up against the enemy, he won't move away from the enemy. But if he's roaming and he's outside of this range, then he'll actually go into the range. But if he's up against the enemy, he does not. I don't know why. I haven't figured it out. I don't really care at the moment. But yeah, that's the system. That's everything. It's pretty simple to look at. Excuse me. Pretty simple to decipher what's going on. Very simple to debug and see, okay, what's happening, what scores are happening here, like 0.9 and 0.9. But because you're not in melee range, he's not going to move to melee until he's out of stamina, because he's done ranged attacking. So that's pretty predictable, I guess you could say. Same thing for when he runs out of everything. He's like, okay, he's going back to roam. 0.9, 0.9, but Melee range was false, so he was ranged attacking. But yeah, that's it. The next thing I need to do is when I train, I need those stats to then come over into the combat stats and have those actually affect different things. So like, actually, let me get into the top-down map. Yes, save stuff, thank you. So we have speed training, we have strength training, we have health training right now. Health training, obviously increase HP, but my thought is when your creature, companion, whatever, loses a match, there's a chance that he could get injured. Very small chance, but it can happen. After 3, he dies. I want the thing to die, whatever it is, doesn't matter. This isn't Pokemon, they don't just faint, they die. But if you increase their health, maybe their strength, I haven't figured out which yet, but increase their health more, the injury chance lowers because they're more, they have more vitality, they're sturdier, I guess. Strength training, attack damage, maybe even like armor bonus if they're strong because they've got, you know, muscle. And then speed training, attack speed, maybe mana regeneration. Oh, strength, also stamina regen. Maybe health under stamina regen. Sorry, guys, itchy nose. Yeah, so the blue could be dodge chance, movement speed, attack speed, that kind of thing. So do the trainings and then output the values. The values then affect their values on the combat, and if everything syncs up and is working constantly, that's phenomenal. I'm happy. That's the end of the next step. So that'll be the next thing you guys see on the next step vlog. Until then, thank you for watching and sticking around this long. I know it was kind of boring, but I haven't seen a whole lot of people showing off the utility system, if you call it that, or the action score decision making system that's not tied to behavior trees. So it was very important for me to actually do it myself and to show you guys what I did. Hopefully it helps somebody else in the future. But other than that, thank you again, guys, and I hope to see you again later. See ya.